Assalamu alaikum doctors, welcome to my YouTube channel MBBS and BDS lectures. Today is the fourth video of repeat revision course of fixed partial denture, which is very important for NLE, MDS, NBD as well as for BDS students. In this video we will discuss about connectors in detail, because in our previous videos we already discussed about introduction to fixed partial denture and its in its component. We already discussed in detail about Pontic retainer. Now in today's video we will discuss about connectors in detail, and connector is the part of fixed partial denture which connect Pontic with retainer. Now in this connector video we will discuss about definition, requirements, types of connector, and each type in detail. First, how we define connectors. Connectors are an essential part of fixed partial denture that join the individual retainer and Pontic together. It is defined as the portion of the fixed dental processes that unite the retainers and Pontics. It unite the retainer and Pontic. Now come to the requirements for appropriate connector design. In requirement, it should be sufficiently large to prevent distortion or fracture during function. It should provide the adequate space for effective plaque control. For cleaning, its shape, size, and position of connector determine the success of processes. What shape of connector, what size, and where the position. Tissue surface of connectors should be highly polished, should be highly smooth. It should not irritate the tissue. Tissue surface of connectors should curve labiolingually to aid in cleaning. In the aesthetic zone, the connectors are usually placed lingually. Now come to the types of connectors. There are two types of connectors. One is rigid connectors and second is the non-rigid connectors. And actually rigid connector we give in a condition like in fixed partial denture. When there is no movement in the denture, we give rigid connector. And non-rigid connector we give in that cases where there is a fire abatement cases, and when we use a stress breaker, then we use non-rigid connectors. Now in rigid connector there are three subtypes, and in non-rigid connectors again there is three subtypes. In rigid connector there are cast connectors, soldered connectors, and welded connectors. Second is in the non-rigid connectors there is a dovetail, split Pontic, and cross pin and wing. Now before going to detail, let's we discuss the main points of each type. First, in a rigid connector, the most commonly type of connector which uses the rigid connector. Now in the rigid connector, in cast connectors, what is the difference between cast connectors, soldered connectors, and welded connectors? In cast connectors, between the retainer and Pontic, in that space where we give connector, in that space we flow the wax, and then this flowable wax is replaced by cast. But the Pontic and retainer mean the metal by which we make Pontic and retainer, the same material have same melting point. We flow between these Pontic and retainer, and it will act as a connector. It will replace the wax pattern. But in Pontic, retainer, and connector, in all these three components, the metal is have same melting point. This is the cast connector. In soldered connector, the space between between the retainer and Pontics, here we flow in soldered connector we flow the metal which melting point is less than the metal of Pontic and retainer. This is a soldered connectors. Next is the welded connectors. In welded connectors, again the metal which we use per connector is have less melting point as compared to retainer and Pontic. But in welded, like we do welding, we soft the edges and then we apply pressure. This is about rigid connectors, mean cast, soldered and welded. Now come to the non-rigid connectors. First is the dovetail, or also known as key and keyway. Here we make key and keyway. In a Pontic there is a key, and in retainer there is a keyway, and key and keyway are close together. This is known as dovetail, or key and keyway are also known as Canon mortise. Second is a split Pontic. Here we split the Pontic into two parts, and this two parts of Pontic, one act as a key and other will act as a keyhole. Next is the cross pin and wing. In cross pin and wing we make two metal wing, and then 0.7 mm of hole we created between retainer and Pontic. Then we place these whole wing on one another and pass the same size pin across that. This is the cross pin and wing. Now come to the detail. In detail, first is the rigid connector. They are the mostly widely and commonly used connectors in fixed bridges. All the components are rigidly joined. Forces are distributed over two or more abutment teeth. In rigid connector, the first is the cast connector. They are made by flowing wax between the wax pattern of retainer and Pontic such that the bridge is casted in a single unit. What are the advantages? They are stronger than soldered or welded connector. They are convenient as they do not require additional procedure of soldering. What are the disadvantages? They have more chances of distortion, especially in the long span bridges. Multiple unit bridges are casted preferably in several sections and then soldered to get best result. Now come to the second is a soldered connector. Here there is a soldered connector. There is a soldering gap of 0.25 mm is recommended to allow proper flow of soldered between Pontic and retainer. In soldered connector, these involve the use of an intermediate metal alloy whose melting temperature is lower than that of parental metal. But in cast connector, the material we flow have same melting point as metal of Pontic and retainer, mean parental metal. The parts being joined are not melted during soldering but must be thoroughly wetted by liquefied solder. Here we apply liquefied solder. Soldering is a process in which the pillar metal has the melting point below 450 degree centigrade or 842 Fahrenheit. And brazing is a process in which the pillar metal has a melting point above 450 degrees centigrade. Mean, what is soldering and what is brazing? In brazing, the pillar metal which flow between two metal have the melting point in brazing is above 450 degrees centigrade, but in soldering it below 450 degrees centigrade are also known as in Fahrenheit 842 Fahrenheit. The recommended width between the two sections surface to be soldered is 0.25 mm. This is 0.25 mm, and this is the MCQ's point. Per soldering, the recommended width is 0.25 mm. Large gap, there should be no large or small gap. Large gap decrease soldered accuracy, whereas small gap hindered proper solder flow. They are indicated in long span bridges where multiple units are involved. They are also indicated in cases where pontic and retainer are made separately. For example, complete metal crown retainer joined with a metal ceramic pontic. Now come to the welded connectors. It is another method of rigidly joining the metal parts. Here the connection is created by melting adjacent surface by heat or pressure. A pillar metal whose melting temperature is about the same as that of parent metal can be used. A pillar metal whose melting temperature is same. Remember, in welded connector and cast connector, a filler metal whose melting temperature is same as that of parent metal is used. But in soldering, in soldered connector, the flowable metal have less melting point as compared to the parent metal. Now come to the four types. There is four types is a loop connector. In loop connector, here we make a loop and the connector are placed between pontic and retainer in the palatal mucosa. It is used when the diastema is to be maintained in the fixed processes. It consists of loop on the palatal aspect, complete loop of wire that connect adjacent retainer and pontic, because it is used when diastema is to maintain in the fixed processes. It can be casted with a sprue wax or made with a platinum gold palladium alloy, where adequate space should be provided for effective plaque control. Mean the loop connector, it can be casted with a sprue wax or made with a platinum gold palladium alloy wire. Now come to the non-rigid connectors. In non-rigid connectors, this is the key and keyway non-rigid connector, which is known as tenon mortise. Here we make a keyway in the retainer and keyway are also known as mortise, and key or tenon in the pontic. This is known as key and keyway are key and keyway, tenon mortise are dovetail. This design consists of a keyway or mortise female component. Keyway or mortise is the female component and key or tenon is the male component. Prepare on the retainer. Female component prepare on the retainer and key or tenon male component attached to the pontic. This is the most commonly used non-rigid connector. In non-rigid connector, the key and keyway or tenon mortise or dovetail is the most commonly used non-rigid connector. The alignment of this design is critical as it must parallel the path of withdrawal of other retainer. Parallelism is usually achieved by means of dental surveyor. Like in the removable partial denture, we already discussed the tooth parallelism we achieved by dental surveyor. The mortise female component may be prepared freehand in wax pattern or with precision milling machine. Alternatively, a special mandrel is inserted into the wax pattern and abutment retainer is cast. The female component is refined as necessary. The male key is fabricated with a autopolymerizing resin and attached to the pontic. Another approach is to use as a prefabricated plastic component for mortise and tenon of non-rigid connector. Now come to the advantages. What are the advantages of dovetail or key and keyway and tenon mortise? Normal movement of tooth is not interfered. In normal movement of tooth, there is no interference if we use key and keyway. With the use of this type of connector, and therefore the deleterious effect to the supporting tissue are prevented. Second, it is advantageous from an aesthetic point of view as it allows simple type of retainers that require less cutting of the tooth structure, which result in a more aesthetic restoration. Next is the it permits the clinician to finish and cement one retainer before the rest of the bridge is cemented. These do not transmit torsional type of forces from bridge to the interior retainer. Now come to the second is the split pontic non-rigid connector. Here we split the pontic into two parts. One acts as a key and other acts as a keyway. Split pontic. This type of connector was educated by R.P. O'Connor and W.F. Cogman and C. Bemis in 1986. This is used only in cases with a pier abutment. We already discussed about pier abutment. Is abutment mean on the both sides of the abutment there is a edentulous area. This is used only in cases with a pier abutment which require excessive preparation due to tilting of teeth. The connector is incorporated entirely within the pontic. The pontic is split into mesial and distal segment. Each of these segments is attached to their respective retainer. First, the mesial segment consisting of mesial retainer, pontic and pier retainer is fabricated. The distal arm of the connector is attached to the pier retainer and is shaped like tissue contacting area of the pontic. The distal segment is then fabricated with a keyway to fit over the shoe. Servable is used to align the two segments. Cement is not used between the two segments of pontic. Next is the last one is the cross pin and wing. Here we make a two wing. One wing we attach with a retainer. This is known as a retainer wing component, and one wing we attach with a pontic. This is known as a retainer pin retainer pontic component. Then we place these wing about one another, and these both wing have a hole of 0.7 mm. And then we place this hole about one another and then pass the a pin on these wing. This is known as cross pin and wing. It consists of a two-piece pontic system that allow the two segments of the bridge to be rigidly fixed. It was educated by F.C. H. Miller and E.E. Perry in 1994 in cases of tilted abutment. Here the path of insertion of each tooth is made parallel to its long axis. A vertical wing is attached to the mesial surface of the distal retainer. The wing should be fabricated such that it aligns with the long axis of the mesial abutment. The mesial wing along with the distal retainer is termed as retainer wing component. The pontic is attached to the mesial retainer and designed to fit to the wing in the retainer wing component. The pontic along with the mesial retainer is termed as the retainer pontic component. The retainer pontic component is seated finally after fabricating the retainer wing components. These are aligned on the working cast, and a 0.7 mm pilot hole is drilled across the wing and pontic using a twisted drill 0.7 mm pin hole, a pilot hole. A rigid pin of 0.7 mm same diameter we pass between these holes. A rigid pin of 0.7 diameter is fabricated using the same alloy to avoid galvanic corrosion. A pin of 0.7 mm dimension is casted with the same alloy. Next is the distal retainer and wing assembly are cemented first. The retainer pontic component is cemented. The pin is seated within the pin hole created on the pontic and wing with the help of mallet and punch. This is all about cross pin and wing. Now today our connector topic is complete. We already discussed about connector definition, requirements and its type, rigid and non-rigid. And then in rigid there is a cast, there is the soldered and welded, and in non-rigid there is a key and keyway, and next is the split pontics, and last is the cross pin and wing. Now today our topic is complete. If you like my video, press the like button and share this video with your friends. If you are new to my channel, subscribe my channel by pressing the red subscribe button, and also press the bell icon in order to receive my each new video notification. For watching my videos, I am very thankful to you. Thank you very much.